Okay, Jerry the Plater here. We're going to do a quick shoot, show you how we plate the inside of waveguide. This is a piece of WR15 waveguide that we're getting ready to plate here. It's come to us from our friends at the Low Noise Factory. They've decided they need to lower the loss of this stainless steel waveguide. So we're going to put it onto our plating fixture, threading the platinum wire down the center of the waveguide. Putting the locating pins into place there. Now we tighten up the 440 screws. If you watch the waveguide, you're going to see it pull off to one side as I tighten that screw. See it moving? I want to tighten them uniformly from side to side, just like when you're tightening the lug nuts on a car wheel, changing a flat tire. Don't put all the force to one side. Work back and forth a little bit. Just standard mechanical practice. And when you've done that evenly, that waveguide will be running straight down the support channel. This is a nice piece of waveguide to be working on. WR15, it's quite big. You don't have to worry about the wire shorting out. It's just moderate tension on the wire. Nice and straight, you're not dealing with any bends at all. Okay, now this part can be a little bit tricky. We've got to thread the wire in through the second stuffing box. If I get lucky, it'll find its way all the way through without too much trouble. I'm hitting the first little internal hole that I've got to line up with. We've hit that. Okay, now we're not coming out through the stuffing box clamp. I'm going to loosen these screws on there a little bit more. If I'm lucky, I won't have to take this off and the wire will come through. Straighten that just a bit. Going in the hole. Got to hit the first hole in the plastic body. There we go. Okay, but we're not coming through that external clamp. It's not a big problem. We just remove two screws here on the clamp. When I say clamp, this is a piece that clamps down on a couple little O-rings that are around the wire. It gives us our more or less watertight seal. Okay, we're going to get that wire through. I think you can see the two O-rings here that are just caught on the end of the wire right now. And we're going to slide our clamp on. Keep those O-rings in place. Stretch the wire. Get the locating pins in. We'll go ahead and tighten this end down. Onto the waveguide flange. Okay, we're attached to the waveguide. We're going to tighten up these screws, pushing the stuffing box towards me so that this edge of both pieces is towards me so that the waveguide is properly aligned, kept in a straight line. Okay. Now we can lift this up. Hope we're still on camera. Push the O-rings down. Got this guy going in place now. minor trick here. We're going to tighten both of these screws up. Again, alternating from one to the other, maintaining uniform tensioning across a piece. Not straining the piece or the plastic too much. So clamp this up fairly tight. Okay, our next step in assembling this is to tension this wire inside the waveguide to allow the wire to slip through the little stuffing box through that O-ring here. I'm going to back off each one of these screws about 1/8 of a turn or 1/4 turn. So now the wire will be able to slip fairly easily through there, but we've still got a decent seal around the wire. Take another little clamp here. This is part of our tensioning assembly. This is going over the wire. Over the wire. Up against the block that clamped down on the O-ring. Then we've got a little clamp piece here that goes in. Tiny Allen wrench. Okay, so we've clamped down on the wire now between the Allen wrench and that little clamp piece. Don't want to clamp too hard or you can break the wire. That's learned with experience. And now we're going to turn these two jack screws, again uniformly, back and forth to put a modest amount of tension on the wire. How tight do you make these? Well, if you break the wire, you've made them too tight. But normally, just by having my fingers on the Allen wrench, not grabbing the end of it, just with my fingers gripping the wrench, the shaft of the wrench, I get to about the right tension. Could probably go a little bit tighter than I need to. The wire is going to break on you every now and then. If you get through 10 or 12 pieces without breaking the wire, you've done good. This is just another little judgment call. You learn from experience. If the wire's not tight enough, you'll have a short circuit inside. The wire will be sagging, but on a piece of this size, it doesn't have to be excessively tight to be running pretty much down the middle of the waveguide. Okay, so now we're going to move over to the sink where we do the actual plating. And you might not sure how we are on the focus here. Let's see. You've got a good look at the jack screws and how we do our tightening on the wire. Okay, we've already done an area calculation on this piece. We're about 1.9 square inches. 1.9 square inches means 125 milliamps will give us 10 amps per square foot of current. That is our nominal plating current. I'm going to hook up the electrical charge, negative to the waveguide, positive to the anode wire. Switching on my power supply, seeing I've got a little bit of leakage current flowing, but I certainly don't have a short circuit. Hook up our suction line, hook up our inlet line, and let's turn the pump on. I'm going to run a little water through here first. I think wetting the waveguide with a bit of water might be a good idea. Might not make any difference whatsoever either, but I've gotten into the habit of wetting it a bit, checking the fittings that way too to see that we've got a flow. Okay, now we're going into the sulfuric acid. Got the power supply set initially for 130 milliamps, 10 amps per square foot. I'm going to raise that up to a full amp, about 80 amps per square foot. That's our cleaning current. And we're going to let that sit for about 10 minutes now.